Well, hello Internet, and welcome to my C# tutorial. You guys have asked for it, and I did my best to cover pretty much the entire C# language in this one video. In the description underneath the video, you'll actually see links to all the individual parts, so not only will you be able to jump to whatever you want to learn about, but you'll also be able to see every single thing that's covered in this video. So I have a lot to do, so let's get into it. Okay, so if you are on Windows, you no doubt are probably going to use Visual Studio 2015 or 2013, depending upon what you want to use, Community Edition. And you just go to visualstudio.com or just type in Visual Studio Community Edition. That's what I'm going to be using in this tutorial, however. If you are on Mac OS X or on Linux, you can try out the monoproject.com right here and download and give that a try. Everything here is going to be able to compile on any OS, and now let's jump over and let's start writing some code. Alright, so here I am inside of Windows, and I'm just going to come in here and open up Visual Studio 2015. Sorry about the zooming, some people don't like that. And here it is, and it's going to be real big here in a second. What I'm going to do is I'm going to say that I want to start a new project. And specifically, I want to start a console application because that's going to make it easy for us all to see exactly what's going on and focus on coding, and click OK. And here we go. This is exactly what it's going to generate here on our screen. So let's just start writing some code. We're going to write all of our code inside of static void main right here. And let's just start off with the simple stuff. Comments, just 2 slashes, there's your comment, and then your multi-line comment is /* and multi-line blah 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 and star, and there you go. So we got comments out of the way. Now we're going to be outputting everything onto the console. So in this situation, I'm going to say console dot. If we type in write, there is not going to be a new line, and if we type in write line, there is going to be a new line, and we can just say hello world and get the hello world thing out of the way, and then we can execute that, and you're going to see that there it is. Hello world, da 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 da, opened up in the screen. Don't worry about all this stuff right here. Alright, so let's continue. If you wanted to come in here and get input from your user, you could say something like, what is your name, like that. And maybe you want to use just right here because we don't want to put a new line after that. And then it's so easy to get user input. We're just going to come in here. Well, first we're going to say that we want to store a string. That's how the input comes in. And we're going to store it in a variable named name. And just like everything else, you can use letters, numbers, underscores, but you should start off with a letter. And we're going to say console and read line. And that's how we're going to be able to get input. And then we'll be able to come in here again and go console and write line in this situation. And then if we want to output information to the screen, we could just go hello. I'm going to put a space inside of there. And if we want to combine 2 strings, we can just type in name with our variable name like that. And that is how simple it is. And we can execute it. What is your name? And I can say Derek, and it will say hello Derek instead. Let's get into data types. Now we have booleans. And a boolean is either going to have the value of true or false. So can vote, for example, if we want to store that inside of here, we could say true or false, and that is a boolean. Characters, we could come in, char is equal to dot A or whatever, and this is going to be able to hold a single 16-bit Unicode character for us. And the little lines there is just there because it is saying, hey, you defined this variable, but you didn't do anything with it. Now let's get into all of the different numeric types. You have integers, which have a maximum number of that big giant number, and you can actually get that number by just going int dot and then max value with uppercase letters like that. You have longs, which can have a larger non-floating point number, and then once again you can get that value by just going long dot max value and store it over in this variable. Decimals are actually massively huge, and if you need anything bigger than that, you could go and take a look at big integers, and once again you can get that value by just going max value. Floats are going to have very large numbers as well. However, they're only going to have 7 decimals of precision. That means if you go in here and try to create a float that is more than 7 decimals, that it is going to cause errors and it's not going to be accurate. If you need something even bigger, go for doubles. For the most part, you're going to use doubles anyway. You can see how large they are, and they have 15 decimals of precision, which is considerably better. So there's a rundown of all the major different data types you're going to use, being ints, longs, decimals, floats, and doubles. Once again, if we want to come in here and combine our strings, we could do so with our console and write line and just say something like max int And all the code, by the way, is available in the description as well. And of course, it is all free. There we go. And you can combine not only strings, but you can also combine strings with any other different data type this way. And you can see right there, it printed that out on the screen for me. Another different data type that is available to you is var. And basically, the var data type is defined whenever the program is compiled, and then its value isn't going to be able to be changed. So we could say something like var another name is equal to, and it's automatically going to say, okay, this is a string because the data that you stored inside of there is a string. However, we wouldn't be able to come in there thereafter and say another name and give it a value of 2, for example. That is going to cause an error. So this is a shorthand way for us to create a variable based off of whatever we assign to it. However, remember, we're not going to be able to change it to some other data type because this is considered an integer. The thing that is interesting is we can come in here and actually get the type for our data type that we have here. So let's just go right line, and we could say something like another, make sure you put double quotes around this, another name is a, and if you want to format or throw in different pieces of data, you can just put inside of here, you're going to start off with curly brackets and then 0, and then the next piece is going to be curly brackets and 1. We'll get more into that here in a second. And then we can come in and get the data type for another name by just going another name and then get type code and execute, and you can see another name is a string. So now let's get into the different math operations we can perform. You can see a whole bunch of them right here. We can add, subtract, multiply, divide. This guy right here is a modulus character, which is going to get us the remainder of this division. And you can see right here how we can increment different values, and we're going to see exactly how they work, as well as decrement. There's the increment and decrement shorthands. And then you can also see there are additional shorthands. This right here would be equivalent to saying I is equal to I plus 3. So this guy right here is just the same as that. This is just a shorthand version of the same thing. You can see right here, if we come in here and add, this is actually a remainder operator. So you can see it goes in there and throws the decimal point in there as well. And you can see right here the way that this is operating with this shorthand notation. See right here we have it a value of 0, and you can see it prints out a value of 0. So you might be saying, what's going on here? Basically what it's doing is it's going and getting the current value of I, putting that inside of there, and then it's performing the addition right here. And then when that's the same reason why it jumps up to 2 is it whenever you put the plus plus ahead of your variable like you have right here, it goes ahead and performs the addition before it transposes it inside of here and prints it out on the screen. Same exact thing happens whenever we're decrementing, and you can also see exactly how this shorthand notation works right there. So that is how you perform your basic arithmetic. Now let's take a look at a casting and how exactly that works. Now basically, if no magnitude is lost, casting is going to happen automatically, but otherwise you're going to have to set it up like this. So let's say we have double and pi is equal to 3.14, and we want to convert that into an integer. You can call this integer pi is equal to, you just put little brackets inside of there and what you want to cast it to, and then the thing that you want to cast. And of course, make sure that you always end all of your statements with semicolons. That is a requirement. So pretty simple. If you want to cast from one to the other, you just go and put inside of there whatever you want to cast to. As for math functions that are built in, there are a whole bunch of them. Here are some of the other ones. And what the heck, I might as well just run through a couple of them just so you can see exactly how they all operate. So let's go and create ourselves two doubles. Number 1 and number 2. And you can see here we can get the absolute value with this function right here. We can get the ceiling, which is going to round up the value. Floor, which is going to round down. Max, you're going to send it two numbers. It's going to give you the maximum number or the largest number. Min is going to do the opposite. You can do the power. You can do another round. And here is square root. And you can see exactly how all of those operate right here. So absolute value, 10.5. You can see ceiling is going to round it up, floor is going to round it down, max is going to give you the maximum value, min is going to give you the minimum, and you can see the power operation and rounding and square root right there. So there are some of the most common math functions you're going to use. Something else that we'd like to do a lot is to generate random numbers. And let's just go and create a random is equal to, and you're just going to go new, random, and then inside of here we can do another console write, and let's say that we want to generate a random number between 1 and 10. We'd just be able to come in here and then go rand dot next, and we're going to, if we want 1 to 10, we have to go up to 11, right like this. And if we execute that, random number between 1 to 10, and you can see right there is the value of 5. So there's a rundown of a whole bunch of different things we can do math related inside of C#. Now let's go and take a look at some of our conditionals. Now the relational operators we're going to have available are all the same you're very well used to. Less than, greater than or equal to, and not equal to. And then with our logical operators we're going to have and, or, exclusive or, and not. And I'm going to show you exactly how they work. So let's just come in here and let's go over how if statements work. So let's say we have int and an age, and let's give it a value of 17. You can then come in and go if, and we're going to use two brackets here. Age is greater than or equal to 5. And this is going to allow us to do two comparisons at once. Age is less than or equal to 7. Then we're going to put in our curly brackets and define what happens if that comes back as true. For this to come back as true, since we're using and here, this has to be true and that has to be true. We'll say something like go to elementary school. Now likewise, we can continue making comparisons just by going else if, and then we could throw in another conditional inside of this. Age greater than 7 and age less than 13 in that situation. Once again, we could do another console write and instead change this to middle school. And then finally, as a default, if we get through all of those, we can say else, console write, and we could say go to high school. And there you go. That's exactly how if, else, if, and else work, as well as the relational operators and the logical operators. Want to see an example of how the logical operator or works? We could also come in here and go if age is less than 14 or age is greater than 67. You could then come in here and say something like you shouldn't work. That's not a political statement right there. That's just based off of retirement ages and when it's legal to work in the United States anyway. All right, so there we go. And you can see that this is only going to come back true, or this is going to come back true if either this is true or that is true. And of course, we could use the exclusive or, which is going to only come back if one of them is false and one of them is true. But this was the one you're going to use most of the time. Another thing we can do is go console write, and just to demonstrate how not works, not true, it's just going to take whatever you have here and it is going to give you the absolute opposite of it. So we can put not true, for example, right like this. And if we execute it, you're going to see not true is equal to false. Also take a look at the ternary operator, and it's going to allow us to assign a value based off of a condition. So we'll put a boolean in here, but this could be anything. This could be an integer or a double or anything. And we're going to say if age is greater than or equal to 16, and we're going to put a question mark inside of there, and then we'll put true and then a colon and false. Basically what this is saying is if this value or this condition comes back true, we want to assign the value of true to can drive. If it comes back as false, we're going to assign false to it. Like I said, we could also come in here and do something like integer and then assign some arbitrary number if that is how we would like to work with this instead. But that is how the ternary operator works inside of C#. Another condition that we can use is the switch statement. Yes, we have switch statements. We could say age, come inside of here, and we're going to be able to go case 0 like this, and then in the case that age has a value of 0, we could go console write, and we could say infant, and you're going to have to put your break statements in here to jump outside of there, otherwise you're going to get errors. You're also going to be able to come in and stack these up, so let's go case, and then we could also check case 2, and in that situation we could type toddler out on the screen. So if the value of age is either 1 or 2, it's going to perform this operation that's inside of there. Another thing we could do is, this isn't specific to switch statements, but you can use go-tos inside of C#. You could do something like go to cute, and then we could jump outside of this like this and then type in cute with a colon like that, and this would jump completely out of the switch statement, and we could say something like toddlers are cute or something like that. That is how go-to works inside of there. You can see there you are, there's a label, jumps to that. Hopefully you will almost never use that because go-to statements can cause major nightmares. And then finally, of course, we're going to be able to come in and define a default situation if nothing else matches, and in that situation we could just say child and then throw our break statement in. So there you go, that is how switch statements work, if, ternary operators, as well as go-to. Now let's jump over and take a look at looping. Now with looping, we're going to continue executing statements as long as a condition is true. So in this situation, we're going to create an integer here, give it a value of 0 because we're going to need a value that is going to increment over and over again. And I'm just going to call this int I just to keep this nice and simple. Let's first talk about the while loop. And in this situation, we're going to continue looping as long as I is less than 10. I could, however, come in here and say if I is ever equal to 7. In that situation, I want to do something different. I'm going to increment the value of I. Always have to do that. If you ever have any sort of errors with your loops, they probably have something to do with not incrementing. In that situation, what we're going to say is continue. So if I is equal to 7, what we want to do is we want to increment the value to 8. Right here, I is now going to be equal to 8. And then we're going to say we want to continue with our loop, which means we're going to ignore everything that comes out right here. And we're going to jump back up to the loop and then continue working with what we got right here. We could also come in and say if I is equal to 9 in that situation. We can use our break statement again, which is going to jump us completely out of the loop. No more while, no more checking anything. We are all done. And if I is not equal to 7 or 9, we could do something like this. If we want to only be able to print out odd numbers, we could say if I remainder of 2 is greater than 0. Well, in that situation, we want to print out our value of I and do it right like that. And then, of course, we want to make sure that we increment I before we leave our while loop. So this is going to come in here. The reason why this is only going to print out I if it is an odd value is here, if we would take like a 4 and then do modulus of 2, that is not going to give us a remainder. So we're checking for a remainder, and the remainder would only occur if it is an odd number. And that is the reason why only odd numbers are going to print in that situation. And if we go and execute this, you can see it prints out 1, 3, and 5 right there. Now, the other looping operation we're going to take a look at, we're going to take a look at all of them. Well, we're also going to take a look at do while. And do while is basically going to be used instead of while whenever you want to guarantee that you are going to definitely go through the code in the loop at least once before you check if you should continue cycling through the code inside of the loop. And this is actually quite useful. Let's say that we have a string that we have the name of guess, and we want to cycle through this loop and consider or continue getting input from the user until they guess the proper number. So we can come in and go console, and we could say something like guess a number like that. We could then go and get the user input and store it inside of guess by going console read line, just like we covered previously. And now what we're going to do is the while part is actually going to come after the do part. So you can see right here, this code is definitely going to be executed at least one time, because after we go through it the first time, we're then going to say not guess equals, and this is how we check for equality with strings. So we're going to put 15 inside of there, which is a string, and we're going to compare it to the string that was input here by our user. So what we're saying is while guess is not equal to 15, we want to continue executing this loop over and over and over again. And this is how we check string equality, by the way, is with the string and then equals right like that. We can execute it, and it's going to say guess a number, and we can start guessing numbers until we get to 15, and then we know that we got the right number. There's an example of do while. Now let's take a look at the for loop, which is basically going to allow us to put the iterator and all of its initialization all in one place. So we're going to go for. We're going to define the data type for the guy that we're going to be iterating over, and let's say 0. Then we're going to define exactly how long, or the condition in which we're going to continue execution while I is less than 10. And then we're going to come in here and we're going to say how much we're going to increment each time. And you can, of course, increment this by 2 or 3 or 5, whatever you want to do. It doesn't matter. Then we could say something like, let's say we want to do a similar thing with what we did before. We could say if I sign 2 greater than 0. So we're going to check so that we're only going to print odds out on our screen again. And we could say console right line, right like this, and then put I inside of there, execute it. Oh, and I went and put I inside of there. What did I do wrong? Oh, I put I inside of quotes. No big deal. Got rid of that. Execute it, and we can see that it only prints out our odd numbers. So that is how the for loop differs for it. And we also have another one, which is known as the for each loop, and we're going to see more of this later. Basically, what it's going to do is it's going to cycle through every item in an array or a collection. And a string is actually a collection of characters. And to do this, let's go and get and create ourselves a string. And let's just call this random string is equal to. And now we'll be able to use the for each by just typing in for each, no space. We're going to define the data type that we're going to be pulling from. This is a string, which is just a bunch of individual characters. So we're going to be getting out each individual character. Temporarily, we're going to store it inside of a variable named C. Can be anything. This variable name can be anything. You put whatever. Just don't put char because that's going to cause confusion. And then you type in this string that you want to cycle through, or the collection. Like I said, as the tutorial continues, I'm going to show you how to cycle through other collections. And then we could just come in here and we could print out each one of those individual characters inside of the string out on our screen. And there you can see they are. Here are some random characters. And you can also see it puts out the spaces that are inside of there, because the spaces are also considered characters. Okay, so a whole bunch of things. Let's go and take a look at strings. Now, one thing that's important to know is if you're creating a string, and let's say you wanted to put a double quote inside of that string, how's it going to know where the string ends? Well, we have things called escape sequences. If you wanted to put a single quote inside of there, you just go and put a backslash and a single quote. You want to put a double quote, put a backslash and a double quote. You want to put a backslash, because we're using backslashes, you have to put 2 backslashes just to get 1. If you wanted to go backwards, back 1 space, put a backslash and a B, and there's a new line, and there's a tab. There's a couple other ones, but these are the ones you're going to use all of the time. So let's go and create ourselves a string and do some different string operations. Let's go sample string is equal to, and let's just say a bunch of random words like that. Make sure you put semicolon at the end. And we're going to be able to do all sorts of different operations on this. We're going to print some stuff out on the screen. We can check if the string is empty, for example. And this is something you'll do with if statements a lot. So we'll say is empty, and then we'll just go and get string. We want to use the string class. This is like an object. We're going to get more into objects and so forth as we go on. This is just a nice handy tool we're going to be able to use. And one of the functions that's going to be inside of here that we'll be able to use is null or empty. I want to check both. So we'll say throw our sample string inside of there and then close that off. This guy right here is going to allow us to be able to very easily figure out if our string is null or empty, just like it says. We could also, let's just leave this is empty, and we could say is null, or let's say we wanted to check if it only contained white space. Well, there you go. You just type in is null or white space. And we'll say something like string length. Want to get the total number of characters inside of there. In this situation, we're going to go sample string like that, and then dot and length with uppercase letters and no brackets like that. Execute it, you're going to see, no, it isn't empty, no, it doesn't just contain white space, and the total string length is 23 characters, as you can see right there. Let's go and do a couple other different functions. There's a whole bunch of functions for strings. Let's go console, and let's say that we want to search for bunch, the word right there. So we could say something like index of bunch. Now each of these individual characters are going to be assigned indexes like arrays are. Hopefully you're aware of how arrays work and how indexes work. Basically this is the 0 index. This is the space here is the 1 index, 2, 3, 4, 5, 6, and I messed up bunch. So what I want to do is I want to find out exactly where inside of this string the word bunch actually is stored. And if it can't be found, it's going to give me a value of -1. So you'll also be able to check that with your if statements. If you want to find it, you just type in index of. Pretty simple, pretty much exactly what you would think it would be. And then inside of here, you're going to type in the word that you are specifically looking for and put that inside of quotes. And of course, inside of here, instead of string, we're going to put in the string that we are actually going to be searching for. Let's go and do a couple more of these just so we can see them. Do another one. Let's say that you wanted to get a substring, like you wanted to get, we found bunch and we wanted to be able to pull bunch out of that string. Well, we could do something like, just say second word. Again, we're going to be using sample string because that's what we're going to be searching through, sample string. And let's say that we wanted to start at the second character. Well, first off, we would type in substring. We want to get a sub part of the total string. We want to start, this guy here is going to say, hey, it said index 2. Then you'll say, okay, fine. I want to grab it. I want to start at index 2 and reach the whole way out to index 6. And then I want to store that or print it in this situation. And this is substring. That's a little area. And there you go. And if we execute that, you're going to see right here, index of the word bunch is 2. And then we jumped in there and we grabbed the word bunch and pulled it out and printed it out on the screen. Or we could just store it. We could also, let's create another string. Let's call this sample string 2. And we'll say something like more random words. Do some comparisons between these guys. We could check if these strings are equal. Strings equal. Again, sample string. And to check equality, this is very important. We say equals like that. And then this will be sample string 2. That's how we check equality. We could also do string comparisons. I just like to print these out on the screen. That's the reason why I'm using right line here. We could check if a string starts out with the two words a bunch. So you could say something like starts with a bunch, right, like that. And just to show you exactly how we would put in the double quotes, we could do backslash and backslash. And we could do samp string like this. Starts with. Pretty easy to remember these after you do it long enough, and code completion helps a lot. So we're going to check if that string starts off with the words a bunch, right, like that. We could also likewise go and figure out if it ends with certain values. So ends with words. Words is what I'm going to be searching for in this situation. And again, we'll say samp string is what we're going to be searching for. And I bet you can guess what I'm going to type here. Ends with, right, like that. And we could just come in and say words. And if we execute it, you can come over here and you can see starts with the two words a bunch, comes back as true, ends with the words words, ends with words, and that also comes back as true. And there we go. And you can also see strings are not equal. All right, so a couple other different string operations we can perform here. We could come in here and restore a value or a new value inside of sample string. We'll also be able to come in here and go sample string, and let's say we wanted to trim any white space for the string that is either at the beginning or the end. You just do that with trim, right, like that. You could also do a similar thing by just going trim end if you just wanted to get the white space off the end, or trim start if you just wanted to get the white space off of the beginning. And that's how trimming works. We would also be able to come in here and replace words inside of the string. Let's say we want to store them in sample string just like we did before. We would just go sample string and we could say replace, and we could say what we wanted to replace, which is words, and instead replace it with characters. And that's how easy that is to do. And I could print that out, but I'm sure you know what that looks like. Could also remove starting at a defined index. So we could say sample string equal to and get sample string. And let's say we want to start removing at index 0, which is the very first place, up to index 2. It doesn't take index 2 out. So what we're going to be doing is just removing 0, 1. So bunch is going to be the beginning of the string after we perform that remove operation right there. And another thing we could do is we can create string arrays. An array is just a whole bunch of strings all stored under one name. In this situation, it's going to be names. And arrays can store a whole bunch of different values. Like I said, I'm sure if you're watching this, you've seen other programming languages, you know what an array is. So let's say in this situation, this is how you create an array, by the way. Just type in whatever the data type is for all the values in the array. 2 brackets right there. Then we're going to give it a name. We're going to say new string, and we're going to define exactly how many blocks we want to set aside. And then we're going to, inside of this, store a whole bunch of different values. So let's say neighbors I have or something like that. And there you go. Just created that. We're then going to go into the console and show you how to join all of these into a string. So we're going to convert this array, this string array, into a string all on its own. So we can say name list. We're going to be using the string here, and we're going to say join like that. It's going to join those string array into one big giant just array. And then inside of this we have to define exactly how we want those to be separated. So I want a comma and a space, and then I'm going to define the array name that I want right there. And there you can say names, and then we'll have name list, and then it prints out all of those different guys right there on our screen. Another thing that's pretty important is what we would use for formatting. Basically, I'm just going to show you a whole bunch. So we'll say string. Let's just call this format string. is equal to, if you want to format a string, you just go string, format, and let's define a whole bunch of things. So I said if you want to transpose or move different values inside of here, I'm going to use curly brackets. And in this situation, let's say that I want the data that's going inside of here to be a currency. So it's going to have a $sign inside of it. Well, pretty easy. Just go like this, and then outside of there, we're going to put a comma and 56. That's automatically going to convert it into a currency since I have the little 0 and the C inside of there. We could also define decimal places with this value. So it's like this. In this situation, we're going to say that we require, well, actually the 1 is going to define that I want the second value right here in the comma. That's what that means. Some people get confused by that for some reason. Then what I'm going to do is I'm going to say I demand that there are at least 2 zeros and then 2 additional zeros for the decimal places. So that's going to handle decimal places for me. Here I'm going to throw in another one, and let's just say that the value that I want to put inside of there in that situation is going to be 15.567. So it's saying, hey, I demand that there's at least 2 numbers inside of there and then 2 decimal places. So what's that going to do? It's going to chop off the 7. Then inside of here, we could also define decimal places. And if we put a hash symbol inside of here, what that means is we don't care if you put a 0 inside of there or not. It's basically like I will, whatever, put a 0 inside of there or do not put a 0 inside of there. And that would work if we had a value that looked something like 0.56. So in that situation, it's going to say, well, there's no 0 here, so we're not going to put a 0 here, but we demand that there's at least 2 decimal places. So that's what that means. And then we could also define that we want the thousands separator to come in here for our third or our fourth number in this situation. And we would just say 0, and then we put a comma, and then another 0, and close that out. And then whenever you see this, it will all make sense. And we could say 1000 right like this. And then we want to print this out on our screen. And you can see exactly how it printed all those out in the thousands and da-da-da-da-da-da-da-da. So there you go. There's a whole bunch about strings. Now let's take a look at the string builder. Now, each time you create a string, you're actually creating another string in memory. String builders, on the other hand, are used whenever you want to be able to edit a string without creating new ones. And it's easy to make one. You just go string builder, and let's just call this SB, and we're going to say new string builder. That's what we're going to be building, a string builder object. We're going to be getting more into objects in a second. And if you want to be able to append another string to the end of your string builder, you could use append line if you wanted to have a new line at the end of this. But if you don't want a new line, you could say this is the first sentence. And then you could continue to append. You could also do append format. So append format, say my name is, and then inside of curly brackets, the first thing you want to put inside of there, and I live in, and then you could put the next thing you want to put inside of there, and then you could put in whatever you want to transpose inside of there. So there's 3 different ways. Remember, append line would put a new line after this. If you do not put append line, then it's not going to put a new line there. You could also come in, and if you decided you wanted to delete your string builder, all the information inside of there, just call clear. And then you could also, let's get rid of that. You could also go and call replace if you want to replace every instance of the very first thing you type in with the second thing. So let's say we want to replace the letter A and with the letter E everywhere inside of our string builder, which is going to be a combination of both of these strings that we created right here. And you could also remove characters starting at an index and then up to whatever you put inside of there by going remove. So let's say we want to start at index 5 and go up to but not including index 7. And then let's just output everything on the screen, see exactly what it looks like. And to do so, you need to convert the string builder into a string. So you would go to string and execute it, and you can see right there. This is the first sentence. My name, remember we replaced all the A's with E's, is Derek, and da-da-da-da-da, and I live in Pennsylvania. Okay, so there you go. There's string builders and a rough overview of some of the things we can do with string builders. Now let's take a look at arrays. Now to declare an array, remember you have to put the data type of every single value inside of that array, and then we're going to give it a value or a name or a variable name, and that is how easy that is to set up that. Remember, that is just declaring the array. Not going to be able to do anything with it. If you also want to come in and declare an array and then also define how many items you want to put inside of it, you're only going to be able to put the number of items inside of an array as you define here. So here I have an integer array that I expect to have 5 values in it and no more than that, and that's exactly how you have that set up. And you could also come in and declare and initialize an array, right, like this, new. And then here, whoops, don't put new in that situation. We're going to say 1, 2, 3, 4, 5, blah, 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 blah. And there you go. And it's automatically going to set aside enough space to contain all of that data that you said you want inside of your array. Pretty easy to get your string length or your array length. Let's go array length like that. And let's say I want the second array right here. Just type in length. And there you go. That's going to get you the total number of items you have right there. Of course, that would be good if you want to cycle through all of the different data. Also going to be able to come inside of here, and let's say that we want to get item 0 inside of our array. And just like the strings, the first item inside of your array is going to be 0 index 1, 2, 3, and 4. And if you want to go in there and grab the very first item inside of there, you're going to go rand array 2, and then inside of brackets put the 0, and that's going to output that on our screen. If we want to cycle through our arrays, like I said before, there's multiple different ways to do it. Let's just do this one like this. We're going to start off with 0 because that's the very first item in the array. We're going to say as long as I is less than random array 2 dot length. That's how length is useful. Length is useful in a couple ways though. And then we could print out the information on our screen, and we could also print out the index. So let's say right line, and then we want to put first item inside of there, and then which is going to be our index, and the next one's going to be the actual value that we have inside of there. And then we could say I, and then let's go and get the value out of our array right like this, and then put the value of I inside of there because that's what's going to be incrementing as we're cycling through all this stuff. And another way we could do this, of course, is with our for each block that we have. Again, we're going to define the data type that we want. Num is going to be the temporary holding cell for each item in the array that we're cycling through. Random array is going to be what we're cycling through, and then console write, and then we could just put inside of here num just to keep that nice and simple. Let's execute it just to see all the different things, and you can see right here array length is 5. What is in the index of 0, 1. You can see here it's printing out all the different things, and for each it's also printing out everything right there. We could also come in here and say, hey, what's the index for a specific item inside of my array? So for example, we could say where is 1. So we'll search the entire array for the value of 1, and it's going to kick back the index. And to be able to get our index for that guy, we're going to use an array object, index of, and then we're going to pass in the array name that we're going to be searching for, and then the specific thing that we are searching for inside of that array, like that. And that's how easy that is. Could also come in here, of course, and create some string arrays, and let's just call this names. And I'm going to initialize it from the start, so let's just put in some random names. We could join an array into a string, just like we did before. Let's go name string is equal to, and then we're going to call string join, and we're going to say what do we want between each of those strings. Well, we want a comma and a space, and then the actual array that we're going to be working with, and it's going to automatically join those together and save them into a string. We could also come in and split a string then into an array. So string, there's a string array, call this name array is equal to, and name string, and then call split on that, and then inside of it we're just going to put what separates all those names into strings, which is going to be a comma, and execute that. See, where is 1? It's in the 0 index, and the other stuff didn't really actually do anything. But if you print this out, you'll see exactly how those work. And why don't we just come in here and just create a multi-dimensional array just so we can cover all that. So let's say we wanted to create an integer multi-dimensional array. Let's just say it's going to be a 2-dimensional array. We're going to not put anything inside of there, but we are going to put a comma. Mult array is equal to new, and it's going to be an integer multiple array or multi-dimensional array, and let's say we want it to be 5 by 3. That's exactly how we would define that. We could also, of course, come in and do pretty much the same exact thing and initialize the multi-dimensional array at the same exact time. So multi-array 2, is equal to. This is sometimes easier because it's easier to see how everything's going inside of here. So there we go. And this is how we would separate each individual part of our multi-dimensional array. So 2 and 3. You can see there's another comma inside of there. And then inside of this one, we'll put 4 and 5. And then finally, to close that off, we would just put our semicolon inside of there. We could then cycle through our multi-dimensional array in a couple different ways. We could either use for each, like this. Again, the data type, num in multi-array 2, that guy right there. And then we could print out on our screen just each one of those individual nums, which is where those are going to be stored. Or sometimes we also want to be able to print it out in different ways. So let's say we want to cycle and have access to all of the different arrays. We could also go int x is equal to, remember we're starting off at 0 index, x is less than, and we could say multi-array 2. If we wanted to get the length of it, we could go get length and throw in 0 inside of there. That's going to give us that. And then we could say x plus plus. If you were wondering, you could also go x plus equals to 1, right, like that. But let's just trying to cover everything as I'm going through here as things pop into my head. Okay, so that's going to give us the first part of our array, but we want to get the second part of our array as well. So we're going to go int, and let's say y is equal to 0, and we're going to cycle through this as long as y is less than the multi-array 2. And again, we're going to go get length like this, and in this situation, we're going to put 1 inside of there, and then we're going to increment the value of y as well. And now we can access everything. So we could go console write line, and we'll throw in the first part we're going to put inside of here. Throw like a or statement inside of there, and we're going to get another value inside of that, and then the final actual value that is stored inside of it, right, like this. Now what we can do is come in here and grab x and y, and then to actually get the value that is stored in our multi-dimensional array, we could go multi-array 2 and then throw in x and y at the same time. And we could save that and execute it, and you're going to say it prints out our multi-dimensional array, which starts off in 0, 0 index, and this is the value, and so forth and so on. So there is a heck of a lot about arrays. Let's go and take a look at lists. Now, a list is like an array. However, unlike an array, whenever you add new items to a list, the list is going to automatically resize for you. And how we're going to create a list is we're just going to type list, and then the type of data it's going to contain. Create a number list, and then you just go new list, and then the data type that you want again, and the brackets for the function. And now to add items to our list, we just type in add, and you can just throw in as many different items as you'd like to. And there you go, and you don't have to worry about the size of your list. Another thing that's kind of neat is it's very easy to add an array to your list. So let's just create an array here. And there it is. Now you can just go num list, and of course the data type has to be the same, so make sure that you do that. And then you're just going to go add range instead, and then make sure you put the little dot inside of there. There we are. And then inside of here you just put in the name of the array that you want to put inside of there. Pretty simple. You can clear your list by just going num list and then clear like that, but why would you want to do that? You can also copy an array into a list. So just create a list. Let's go number list 2, new list. Again, the data type you want inside of there. And then in this situation, you pass in the array that you want to put inside of there. And you could also create a list with an array in a very similar way. So let's just number list 3 equal to new list. And then inside of it, we'll just define our array inside of here. So it's an integer array. And then we can just put 1, 2, 3, and 4, or whatever you want inside of there. Let's say you wanted to insert an item into a specific index. Let's just go num list, say insert, and you're going to say first off the index you want to insert into, so the 1 index. Remember, it starts at 0. And there we go, we just inserted that. We could then remove an item specific to its name, so remove 5. You could remove at an index, so remove a specific index with remove at. And then of course you could cycle through your list. Just jump it in here, and just like you would with an array. And you can also see here, if you want to get the length of your list, you use the count function right there. And if you execute it, you can see all of those list items print out right there. You'll also be able to come in here and return the index for a specific value pretty easily. So let's say something like 4 is in index, and we're just assuming that 4 is inside of here. And we could say number list, let's just change this to 3 just to use a different one. And then we'll say index of, like that, and then the specific value that you're looking for right there, and it's going to return -1 if it doesn't find anything. Likewise, you could come in and check to see if an item is inside of a list. So we could just come in here again, and we could say something like 5 in list. We'll just go number list again, and contains, and then the item that we're looking for specifically inside of there. And you could also search for a value in a string list. So let's create a string list. Same exact thing, right, like this, new, and we'll go and create a new string array right inside of here. And we could just put in some names and then close that off. And then we could say something like Tom in list. And then we'll use the string list here instead. So string list, and you're going to do pretty much the same thing. Contains. Another thing that's useful is we could actually use lowercase letters here. However, if you do that, you're going to want to go string comparer, that guy right there, and then ordinal ignore case right there. So what we're going to be able to do is search for Tom, and even though this is lowercase t, it's going to be able to match that right there. And then you want to close that off. And then the final thing we could do also is if we wanted to sort our list, we could go string list and sort, and it's going to automatically go in and sort that alphabetically or numerically depending upon the type of list items you have. Alright, a whole bunch of stuff. Let's go and take a look at exception handling next. Now there are countless numbers of different exceptions. I'm just going to focus in on exactly how exception handling works inside of C# here. And on my website or in the link in the description, you're going to find a link to all of the different exceptions. I'm going to do a divide by 0 exception right here. And we use exception handling anytime we want to keep errors from going out to the user of our software. So let's go int num is equal to int. And if we want to convert from a string into an integer, we use parse or int.parse or double.parse or whatever. It's how we can do our conversions. Because we want to convert the read line, which is a string, into an integer. And then we can print some stuff out here on the screen. Something like 10 divided by, and then we'll throw in whatever they put inside of there, is equal to, and then we'll throw in our final result, and then we'll just put in num, and then we'll put in 10 divided by num as the second thing that's going to show up there on our screen. Alright, so inside the try block we have what we think is going to maybe lead to an error, which is division by 0 error. So now what we have to do is catch an error, and we do that with catch, like you probably would have guessed. And this one's called divide by 0 exception, and I'm going to put EX inside of there so I can get additional information about that exception. Console write, and we could just do something like, we can define now exactly the error that the user is going to see so that they don't just get a whole bunch of junk all over their screen. So we're going to say can't divide by 0. Custom error that we, or a custom message that we will show them if there's an error. Now with the EX, we're going to be able to come in here and get additional information on the exception. So two different things that we can get. We just go EX, and then we can say get type, and then we can say name, and that's going to get us the name of the exception that was triggered. And then we could also come in and get an error message that describes the exception, just like that. Another thing we could do is go throw EX, which is going to throw the exception for another part on another catch block to be able to handle. And another thing you could do is throw a specific, like let's say we catch an exception here and we want to throw another exception. We could go throw new and invalid operation exception, just whatever that is, you know, just to throw something out there. And then we could also put a message inside of here, operation failed, and also along with that throw the exception information inside of there, so we'll be able to handle that and put the semicolon on the outside, of course. And then finally we also would have our default option for catching every exception that isn't caught anywhere else, and that's just catch exception with the generic exception part there. And then we could put all types of error messages. We could just come in here and grab this right now and throw that in there. So there's the basics of exception handling. Just wanted to cover exactly how that operates. And now I think it's definitely time for us to talk about classes and objects. Alright, so I'm guessing you guys know the difference between a class and an object. Basically, a class is just a blueprint we're going to use to define the attributes and capabilities of the objects we're trying to model. Okay, so let's just come in here and create. I'm going to change the class name here to animal, and I'm going to come in here and define some properties for this guy. Now there's going to be different ways we can limit access to the different properties we have. We're going to have public, which means that access is basically not limited. Protected is going to say that access is limited to specific class methods, so the methods inside of our class. However, it's also going to be accessible to subclass methods that we create later on, and private is going to say basically that access is limited only to this specific class's methods. So we're just going to keep this simple and create some public fields or attributes or whatever you want to call them. And C# provides a really easy way for us to set getters and setters. We just do that and it automatically generates them. So we're going to have our animal, it's going to have a height, and we're going to be able to set those using getters and setter methods. And we'll also have weight, and you're going to see what those look like here in a second. Also, for each animal that I'm going to create, it's going to have a string and it's going to have a name. Or why don't we go and have this be sound, specific sound it's going to create. Then I'll show you how to also come in and create your own getters and setters if you'd like to do that. And let's say we have string like that and then name. And since we're going to create our own getters and setters, we'll get rid of that. Well, now what we're going to be able to do is go public string, and I'm going to make this an uppercase name, unlike that. And then inside of this, create the getters and setters. And the getter that I want to use here is return name, and the setter that I want to have here is name is equal to value. You may say to yourself, well, why would you want to do that? Value is very important. Value always has to be used because that's the default for setting any of these different items in C#. So make sure you use that. This, you can have it be anything. And in regards to why are we using getters or setters, basically with the getters and setters, we're going to be able to either limit access with the get part or only allow them to set certain values with the set part. So for example, we could come in here and maybe check to make sure that the name that they want to set for our name property doesn't contain numbers. If it does, we send an error message that says, hey, you need to give me another name that doesn't have numbers in it, otherwise I'm not going to allow you to set the name, and so forth and so on. I figure you got the handle on that. What we're going to need also, now that we have some attributes for our animal object, is we're going to need a way to initialize these new animal objects, and to do that, you're going to use a constructor. Now, the default constructor is automatically going to be created for you unless you create one on your own. Then it's not going to be created. How you would create a default constructor that doesn't receive any attributes is like this. Then what you're going to be able to do is come in here and set values. Now, whenever you create an animal object later on, you're not going to have any way of knowing what the name is. So if you want to refer to attributes for any type of animal object, you use this followed by the attribute you want to set. And in this situation, I'm just going to set a whole bunch of default values for every animal object that's created that isn't passed attributes. You're going to see here in a second what it looks like whenever attributes are passed in. Now we're going to define the weight, and we're also going to come in here, and this is also how you set values with a dot operator like that. And then let's also set a sound, and of course we're going to have the name. I'm going to put no name inside of there just so you can see very easily that there's no name assigned and no sound. And then let's say that we also want to come in here and maybe track the number of total animal objects that are created. Well, how could we do that? Well, and one thing to think about is this is going to bring us to the concept of statics. Well, before I get into that, let me jump in here and just show you how to create the other constructor that's going to set our variables for us, or our attributes. Again, you're going to go public, whatever the class name is, and then you're going to define the data types for everything that's coming inside of here, and sound. And then you're basically going to do exactly the same thing that we did here. We're just going to go, this animal is going to have these values assigned to its specific attributes. So in this situation, we'll say height, and here we'll say weight, and then here we'll say whatever the name is they passed inside of it, and then this is going to be whatever the sound is they passed inside of it. So you can see here where it makes a lot of sense that these animals would have heights and weights and names and sounds, okay? However, I also want to be able to track the total number of different animal objects that are created. Now, does it make sense for an animal to be able to track or count the number of animal objects created? No. In situations in which you get that answer whenever you want to add a capability, but it doesn't make sense for the object to have that capability, that is whenever you're going to use what are called static fields. Now a static field is going to have a value that's going to be shared by every object of the animal class in this situation. And like I said, we're going to call something static when it doesn't make sense for the actual object to be able to perform a certain operation. So a static field attribute starts off with static, data type, num of animals. Okay, so that's what you want to store inside of here, and like I said, this value is going to be shared by every animal object ever created ever. Now you may also want to be able to get access to this static value, so we're also going to create inside of here a static method, and we're going to make it public so anybody can get a hold of it, not just class methods. It's going to return an integer and get num of animals. No attributes going to be passed inside of this function, and it's just going to return num of animals whenever it's called. And another thing we can do here is each time one of these constructors is called, we're going to be able to come in and go num of animals, right like this, paste this inside of here, and then increment that. And then do the same exact thing here, paste that in there, and increment that. And there you go. Now we have some attributes for our animals, as well as the constructors and the ability to go in and increase the number of animals that we have total. Let's go in here and create a couple other different methods for our animals to be able to operate with. We'll go public. This guy right here is going to just print out a bunch of information about all of the animal objects, and this is how we define our methods. So we'll say return string. Another thing that's very important to understand is a static method is not going to be able to access non-static class members. So this guy right here isn't going to be able to access these attribute values up here. It's going to only be able to get this because it is static. Put that in the back of your mind. So this guy right here is going to return a string. So I'm going to say string, and I'm going to format this guy, and I'm going to get all the individual pieces of information about my different animals. This is going to be the name of my animal, and it's so many inches tall, weighs, and then I'm going to get the amount that it weighs, pounds, and likes to say, and then whatever its sound is. If I want to get access to those things, I just go name, height, weight, and sound, and it's automatically going to know what animal I'm specifically talking about. So now I'm going to jump down into the main section and actually create an animal object. Pretty easy to do. Just go animal, and I'm going to call my animal spot equal to new animal, and let's just say 1510 name is spot, as well as wolf is his sound that he makes. There you go. We just created a brand new animal object, and this called this constructor that we created up above. Now you can come in here and actually get the different items for our animal, print them out here on our screen, and we're just going to do it just like we would normally do it. We'll say says and that, and if we wanted to get our specific animal object named Spot's name, we just put spot.operator name, and if we want to get his sound, we just go like that. If we want to call the static method that we created previously, let's go and copy this, paste that there. You could say number of animals, and to call the static method, you're going to type in the class name followed by get num of animals, its name, and that's how that works. So you don't use spot, you need the class name before that, because that static method belongs to the class. It doesn't belong to the objects. And we could also come in here and call the objects method by going spot, and then toString is the name of that guy, and we don't put it inside of quotes, and that's going to output all that information about our animals. And you can see right here, Spot says wolf, number of animals created is 1, Spot is 15 inches tall, weighs 10 pounds, and likes to say wolf. Okay, so there we go. Pretty simple example, but an overview of a lot of things. So I showed you how to create an object method right here with two strings. Let's say that we wanted to also explore something called method overloading. What this is going to allow us to do is actually work with different attribute types, but also use the same method name. So let me just show you. So let's say we have a really smart animal that can perform addition. I'm going to create a new method inside of here, a function, whatever you want to call it, called getSum, and it's going to get an int, and it's going to be called number 1. If you wanted to give a default value to assign if no value was assigned, you would just type in this like this is equal to like that. All right, so that's going to create a default value of 1 if nothing's assigned. Then what this guy's going to do is return num1 plus num2 right like that. Pretty simple function. But we can also, what the overloading part means is, as long as we have different attribute data types, we're going to also be able to accept doubles and then also return doubles. But you have to have different attributes inside of here. But we're just going to go double. This is fine. If you just had double and int, that would work. But in this situation, I'll just do 2 doubles like that. And now what I did was I set it up so that we'll be able to call getSum and pass in 2 integers, or getSum and pass in 2 doubles, and it's still going to work. That's called method overloading. And to see exactly how that works, we could just come in here like that, and then go spot.getSum like this, and then pass in a 1 and a 2, and know that that's going to work, but also come in and pass in 1.4, 2.7, and also know that that's going to work. Another thing that might come of use is you could also come in here and pass in these attributes in the incorrect order. What we'd have to do in that situation is go and say which do we want to assign to. So this accepts num1 and num2. We could go like this, and num1 and then a colon like that, and that's going to work perfectly well. And you can also create objects using what is called the object initializer. So let's say we want to create another animal called Grover. Just go new animal like that, and then come in and assign all these values individually. So equals to Grover, and then sound is equal to, and we could put grr or something like that. And then all you have to do is at the very end of this put a semicolon. There's another way to create objects in C#. And another thing we could do is we can create a subclass of animal, and that subclass is going to get all of the attributes that are defined and methods that are defined in our animal class. And we'll call this one dog. So we want to come out of this guy altogether. We don't want to be in this class at all. We could be in the same namespace. That's perfectly fine. So down inside of here, and if we want to create a class that is going to inherit all the attributes and methods in the animal class, we just put the colon there and animal. There you go. It's pretty simple. We could also come in and of course add in our own new attributes that only dogs are going to have. And we could say get and set, and it's automatically going to generate all that for us. We could also go and create a custom constructor that's going to set favorite food, and we go public dog, the name of the class right there. And if we want to also be able to call the superclass, we would go colon and base. And that's going to allow all the initializations that's in the superclass constructor. All of this stuff is still going to be taking place. So that's really useful, because then we'll just have to come in and go this, favorite food like that is equal to, and then the default is going to be no favorite. And then this, because this guy right here is there, it's going to initialize all the other different parts to exactly what was assigned in the animal constructor. So that's pretty useful. This guy right here, it's going to call the default one right there. We're also going to be able to come in and create a more elaborate constructor that's going to set values that are passed inside by going dog, and we're going to define all the different things that are going to be passed inside. So we have our height and our weight and our favorite food, and make sure that the string's defined inside of there. There we go. So this constructor is going to accept everything that's in the first one and also get favorite food. Now if we want all of this to be passed into the constructor in the animal, we just go base and then pass in height, weight, name, and sound, and it'll take care of initializing all of those different guys. So that means all I need to do is come down here and go this favorite food, right like that, is equal to the favorite food that they passed inside of it. So that's useful. We're also going to be able to override methods in animal inside of our dog class. So let's say we want to override toString. Why don't we just come up here and copy some of this stuff, because it'll be useful. That, and paste that in there. So here we have new string or toString, and we want to override it. If we want to override a method, we type in new, and there we are. Now we're overriding it. We can leave pretty much everything else like this, and then we could just say something like and eats, and then throw in another thing for the favorite food for our animal, and then go favorite food, and it's automatically going to update that. And if we would come in and execute all this stuff, let's go and create a dog inside of here just to show the differences. Go create dog, let's call him Spike, new dog, create that, just a generic old dog. And then if we want to come in and call the toString on that, just to show that the toString is going to work, and we'll be able to, call and set up everything, initialize everything using the base class of animal. Do that. And we could also overwrite that by going Spike new dog, and then pass in some information about our dog. So 15 Spike and grr, whatever. And then finally, let's say that he likes chicken or something. There we go. And we created Spike in 2 different ways. And we could go and call toString again, print that out. And if we execute it, you're going to see here is where we created Spike with no name, and there's all that information. Here is Spike with all of the information, and you can also see that each chicken's on there. So there you go, guys. That is how we create or use inheritance, where we inherited every attribute and method inside the animal class into our dog class. Another thing that's interesting is we're going to be able to implement what is called polymorphism through the use of an abstract class. We could also do the same with an interface, but let's go and show you exactly what an abstract class and interface look like. So let's come down here after dog is all closed out, very much at the end. Basically, an abstract class is just going to define methods that must be defined by those classes that derive from it. One thing to remember is you're only going to be able to inherit one abstract class per class. However, with an interface, you'd be able to inherit multiple interfaces. And another thing that's important to remember is you can't instantiate or create an object out of an abstract class. So let's come in here and let's create an abstract class like this, and its name is shape. Now we're just going to define kind of like what this method's going to look like. It's public abstract. It's going to return a double, and it is going to be called area. So we're going to be able to create different area calculations depending upon the type of shape we're using. Another thing that's important to know is an abstract class can actually contain methods that do things, or non-abstract class. So we could say something like public void say hi, something completely silly, but whatever. And then we could say console right line, and then it's just going to print out hello on the screen. Can't do that with an interface. Interfaces only can contain abstract classes or methods like that, I mean. So only abstract methods inside interfaces, but an abstract class can actually contain real methods that do other things. And we can come down here and go and create an interface just so you know what it looks like. So let's create interface, public interface, and let's call this shape item just to have it be something different. And every single method inside of an interface is an abstract method, so you don't need to put the abstract part inside of there. All you need to do is go double area like that, and there you go. You have an interface, and it is going to say that anyone that wants to inherit this interface must have a method inside of it called area. Same's true up here with shape. However, of course, it's not going to require that you have a say hi method, only if it has abstract like that. Now, what all this means is we're going to be able to come in here and create a new class, and let's call it rectangle, and we want to inherit from the shape abstract class. Well, that's how hard that was. Now you have the requirement to come in here and use the area. It's actually going to give you an error saying, hey, you need to do some stuff and you need to put the shape area, da 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 da. You click on show potential fixes and click on implement class, and there it did. It automatically threw it in there. Now what I can do inside of my rectangle class that I have right here is go private, double, and length like that, and then private, double, width, and then come into the area part right here and say it's going to receive a double number 1 and another double number 2, and then it's going to assign those values to length that is equal to num1 and width is equal to num2. There we go. Well, actually, this isn't the right one to do that with. Let's just come in here and just continue clicking around, doing so many different things. What we're going to do is this is going to be the constructor. Sorry about that. I'm sure it didn't confuse you. And then we'll put the double inside of here like this. Let's just get rid of that. Area is not going to receive anything. There we go. Now we got that inside of there. Now we'll be able to come in here and put the length and number 1 inside of there. So there you go. That's the constructor you'll call when you create rectangle objects. And then the area method that we have inside of here, what it's going to do, override. Anytime you want to override a method, must put override inside of there. And then we'll say return length times width. And there we go. Now we have a rectangle that's going to calculate area for us. But the reason we want to set this up right here is we want to also be able to calculate using other different types of shapes. Another different type of shape we're going to work with here is a triangle. Just copy a lot of that. So I'm going to change the name from rectangle to triangle. Still going to be a shape. It's going to instead receive a base. I can't use the word base because that's a keyword in C#, so I'm going to just type in the base. And then here I'm going to type in height. And this is going to be triangle. This is the constructor again. It's going to receive 2 numbers just like before. The only difference is in this situation, it's going to say the base like this. And then this guy right here is going to say the height. And then I'm going to be able to come down inside of here and leave area. Remember, it has to use area. And it's going to calculate area in a little bit different way. We're going to go 0.5 times, and then we'll go the base like that times height. And you can see that we have two different shape classes here that are going to allow us to calculate area in different ways. While I'm here in rectangle, why don't we talk about operator overloading? Kind of cool. Basically, if we wanted to be able to figure out ways to use an operator of addition to add rectangles together, could we do that? Yes, we could. So how you do it's actually pretty easy. We're going to go public. This is going to be a static method. It's going to return a rectangle. And if you want to overload an operator, you go operator, and then you follow that with whatever operator you want to overload. So there's a plus, that's what I want to overload. And what this is going to do is it's going to receive rectangle, let's just call it rect1, and another rectangle, we'll call it rect2. And it's going to define exactly how these two guys are going to add together. So we're going to say double, and I can get my rect length for my new rectangle I'm creating right here by going rect1 and getting its length plus rect2 and getting its length. So there's a brand new length for my brand new rectangle that's going to be used whenever I want to add rectangle objects together, which is really neat. And then this one's going to be the width like that, and here I just change this to width instead and change this to width. And then what I can do is just return a brand new rectangle object using the combined length and width, or whatever you'd want to do. So that's operator overloading inside of C# with the addition. But you can also do this with pretty much every other operator that you can think of. Really neat. So now let's jump back up here into our main class and play around with these different guys. We can get rid of all this. And now I'm going to show you how to implement polymorphism through the use of an abstract class. So I'm going to create a shape, call it rectangle, is equal to new rectangle 5, 5. Let's give it that value right there, or pass in those two attributes. And then I'm going to create another one, also a shape, but this is going to be a triangle. And we'll just call this tri like that. And here, see, these are both shapes, even though this one's a rectangle and this one's going to be a triangle like that. And what's neat is this is polymorphism. It's automatically going to call the right area method depending upon this, even though these are both shapes. And you'd be able to throw these guys into shape arrays and do anything you want, because remember, an array can only accept one data type. So you can throw a whole bunch of shapes in there, but they're actually rectangles and triangles, and it's automatically going to calculate the proper area. So let's go and look at it. So we'll go area like this, and to calculate that, you just go rect and area, call the area method right that. And then we're going to do the same thing for our triangle, this, and this will just be try. And then we'll just throw a try inside of here as well. And why don't we take a look at overloading. So we'll go rectangle where we overloaded the plus sign. So we'll create a new rectangle. Let's just go and throw new inside of here like that. And pass in 5 and 5 like that. And then we'll add it to another rectangle. And throw 5 and 5 in there like that. So we're using this guy that we overloaded. So we'll be able to add two rectangles together to create a new rectangle. And then we'd be able to come in here and console write and say something like combined rectangle area is going to be equal to, and we'll be able to come in and go combined rect like that. It's going to work. So cool. And you can see right here the area for the rectangle is 25, the area for the triangle is 12.5, and the combined rectangles have an area of 100. So many different things covered. Hopefully they all made sense. And of course, leave any questions you have below. I answer every question I get. And now I want to talk about generics and generic class in general. Now basically why generics are really cool is with a generic you don't have to specify the data type of an element in a class or in a method. It's going to automatically work. And let me just show you how they work. Make a lot more sense whenever you just see one. So let's create a class and let's call it key value. And it's a generic, so I do not know what the data type for the key or the value are going to be. T value like this, and then inside of it I'm going to go public T key, give it the name of key. It's going to have getters and setters, but I don't know the data type for either one of them. Public, create another one. This is going to be T value like this. So it's going to contain each object of type key value is going to have a key and a value. Alright, so we have that all set up and we don't know what their data type is. If you want to create a new one, you just go key value, call the constructor just like anything else. T key, give it K, and then TV. Once again, we're defining these bizarre data types. We're not giving real data types here, but they will get real here in a second. And then we can say something like key is equal to K, and then value is equal to v. See, we've gone quite some time here and we still don't know the data type we're dealing with. That's because we can deal with pretty much any data type. We could then go public and show data for our method, and then here we could throw out some information on our items. We could say something like 0 is 1, and then we could grab the key by going this key and this value. That's going to shoot that out on the screen, and that's enough information. You of course know how to go and create methods and do additional things here. So let's go back up inside of main right here with this guy, and let's create a new key value class object, and here is where we're going to define what we're passing inside. So we're going to say, hey, we're passing in a string, 2 strings actually, one for the key and one for the value, and we'll call this key value object Superman and say new, and then we'll go key value, and then we'll pass in string and string. Have to have the same thing there. We could pass in nothing in regards to values like that, and there you go. And then we could also go in and go Superman key is equal to, and have the key for Superman be the word Superman, and Superman dot value be equal to Clark Kent. And that is how easy it would be to create that. And we could also create ones with 2 different other data types, or any type of data type. So let's create another one, and this one we'll call it Samsung TV like this, and instead of having a string here, we could have this be an integer, and then this could be an integer. We could change them both to integers. Neither of them need to be strings. We'd then have to assign a value of 0 to that guy right there, and then Samsung TV, and we'd have to assign a key for it, but this is an integer in this situation, so 1 2 3 4 5, whatever, it doesn't matter. Samsung TV and the value for that, and we could say something like a 50-inch Samsung TV to describe that. And then we could come in and get Superman and call our show data method like that, and then do the same thing for Samsung TV dot show data like that, and execute it. And I had a little bit of an error here. Go down here, put a comma inside of there, and then we'll execute that, and you can see that it automatically went and put Superman's Clark Kent in there, as well as handled the TV part. So that is how you use generic classes. Okay, so now let's talk about enumerated types. Now basically an enumerated type, or an enum, is a unique type that's going to have symbolic names and then associated values. And we're going to create these guys outside of our class, so we're going to throw them right here. And to create one, we just go public enum and say we want to do something with temperature, making a microwave that freezes and boils and does a whole bunch of other things. I don't know, first thing came to mind. So here it's going to freeze, it's going to have a setting of low, and it's going to have a setting of warm, and then it's going to have a setting of boil. Okay, so there is our enumerated type we just created right there. We could save that. We could also come in, and this is going to get the default value of 0, 1, 2, and 3. If we wanted to give this a different value, we could come in and have the value start at 1 instead if you'd like to do that, but I'm going to keep it this way. So we saved that. It's an enum called temperature. Now down inside of main, what I'm going to be able to do is go and call temperature, which is the data type I just created right there. And let's call this mic temp like that. And I'll be able to set the temperature for it by calling temperature and then followed by low. Just that easily. And I went ahead and threw in a switch statement here that's going to check the value right here, and then, print out different output depending upon whatever the value is set for. And I'm going to execute that, and you can see right here it automatically prints out temperature is low. And I could also come in here and change this to warm, and it's going to also work that way. Temperature is warm. So that's how enums work inside of C#. Now let's take a look at structs. Now a struct is a custom type that's going to hold data from many different data types, and on top of that it can also have methods inside of it to operate on that. So we can create a struct again outside of our class, and let's say we have a struct called customers. There we go. And I could just go and put some customer information inside of here. Private, let's say we want to have a balance if the customer maybe owes us money, and then also an ID number for our customer. Okay, so there's all those different attributes, all of different data types, doesn't matter. We could then provide a way for us to create a customer. So it would receive a string and a double for our balance and another integer for our ID for our customer. And then if we want to assign the values, we would just do it this way. Pretty simple. There we go. So that's a way to create our customers inside of this struct. And we could do all sorts of different things with this customer information, but in this situation we're just going to display information about the customer. And in this situation we'll just do just some information. We'll just print it out on the screen. And to do so, just go name, and to get the name for this struct, just go like that. And then we could do exactly the same thing for the balance as well as the ID, exactly like that. So there we go, the name, balance, and ID. So we're able to create customers, store customers, print customers, and all those other different things. Let's go down, create a customer. To create a new customer, we just go customers, or it's customers is what I called this struct up here, I believe. Yes, customers. So we'll go customers, and we'll have a customer named Bob. And to create a new one, very much like you would create an object, that's how it's set up. And then we could go Bob, create the customer, call that method to create him, pass in Bob, 15, let's say he owes us $15.15, and he has an ID of that. And then we could go Bob dot, and then show customer like this, and there we go, and it prints out all the information about that struct or that customer. So that's how structs work inside of C#. Covering a lot of stuff here. Now let's talk about delegates. Now a delegate is going to be used to pass methods as arguments to other methods, and a delegate can represent a method with similar return types as well as a similar attribute list. And once again, something that's probably better to see. So let's go delegate. This is how you create one, double. And we'll call this get sum. And it's going to receive a double and another double. And there we go. And we're defining this outside of our class. And now what we're going to do is we're going to use this inside of an anonymous method. And let's come down here. And there's lambda expressions, regular anonymous. Let's just talk about an anonymous method. Basically, an anonymous method has no name and its return type is defined by the return that's actually used in the method. So we're going to use this delegate here, get sum, and we'll give ours the value of sum equal to delegate. And then you're just going to define inside of this the number 1 and the number 2, double number 2, and there we go. And this is an anonymous method. It doesn't technically have a name, so we can just go num1 and num2 right like this. And then if we would come out of here, make sure you put a semicolon right there. We could then come out and print to the screen, right line, and we'd also be able to pass this in as a method operator or a method attribute just by passing in sum, using getSum as the data type that we're passing into a method. And we could just go 5 plus 10 is equal to, right like this, and then call this anonymous method by going sum 5 and 10 like that. And then of course make sure that we wrap this inside of our main function like this. File, save it, execute, and you're going to see 5 plus 10 is equal to 15 pops up there on our screen. So that's how you use an anonymous method. Now let's look at lambda expressions, which are kind of similar. Now basically a lambda expression is used to act as an anonymous function or an expression tree. Now you're going to be able to assign the lambda expression to a function instance like this. So we'll go function, we go int. This is just going to work with 2 ints here. And we could say something like, we could give this a getSum like that to assign the value to getSum. And the way these guys work is you pass in the attributes on the left side of the screen. So we're going to give those the value of x and y. Then you're going to put this little equal sign, looks like an arrow, on the right side. And then inside of here, you're going to be able to perform all of your different statements that you want to happen inside of there. So you can see, and this is a lambda expression. Now what we can do, all in this one place, make these calculations. We can do a right line, and then 5 plus 3 is equal to, and then call getSum, invoke, and then pass in 5 and 3, which is going to go into that expression right there, and print that out on our screen for us. There you go, 5 plus 3 is equal to 8 right there. Another thing that is a little bit even more cool with a lambda expression is they're very often used with lists. So let's say we have a list, an integer list like this. Call it number list equal to new list. Throw some values inside here, 5, 10, and 25. What the heck? There we go. So we created our list. Now we're going to be able to use this lambda expression on every single item in this list, like I said before, and we're going to be able to store it in a new list. So we'll go create another list, and this is going to be called odd nums equal to num list that we created a second ago. We're going to be able to say where this comes from something called link. I could do tutorials forever, and I'm probably going to do a longer C# tutorial here soon because there's just so much about C#. So what we're going to do here is we're going to check to see if any of these guys are odds, and if they are, we're going to store them in odd numbers, like this. What we do is you go like this, and you check that this is equal to 1. If it is, then we want to convert it to a list, and then we want to store it over in odd numbers right there. So we just, in this one line, we went and cycled through all the items in the list, checked if any are odd numbers. If they were, then we stored them in this guy. And then we'll throw up a for each block like this, and then we could cycle through all the different items inside of that list right like that, and print them out on our screen. And there you can see 5, 15, and 25 printed out on the screen. And then the final thing I'm going to talk about is file I/O. Now I'm starting to lose my voice, so what I'm going to do here is just explain exactly what's going on. Basically, we're going to be able to use things called stream readers and stream writers to allow us to create text files and then either read or write data to them. Now there's a whole bunch of different ways of working with file I/O inside of C#. This is just ways of saving text data. So I'm going to do here, it's going to say there's an error here, show potential fixes, and that means I need to include a library. And there we are, now that all fixed itself. What I'm going to do now is I have a string array called customers. If I wanted to be able to write to this, I'm going to use the stream writer to create a brand new text file called customers.text, right like that, or cust.text. I'm then going to be able to cycle through all of the different customer names inside of that, temporarily store it inside of here, and then if I want to write it to the file, I just go and go stream writer and follow that with write line and write each individual word inside of there. And then if I wanted to read that information out of my text file, I need a stream reader, which I called SR. I have to define exactly where I want to read it from, and then once again I'm going to cycle through all the different lines of text inside of that text file and output them on our screen. And there you go, guys. That is how we do so many different things inside of C#. I would have did a couple more, but my throat is really rough and messed up. Please leave your questions and comments below. Otherwise, till next time.